If the angular velocity of an object varies with the time as shown in the figure, the corresponding variation of angular displacement with the time is best represented by imagine a line passing through the center of the earth that goes through both the North Pole and the South Pole. This imaginary line is called an axis. Earth spins around its axis, just as a top spins around its spindle. This spinning movement called the rotational motion. At the same time that the Earth spins on its axis, it also orbits or revolves around the Sun. This movement is called circular motion. Rotational motion is more complicated than the linear motion, and only the motion of rigid bodies will be considered here. A rigid body is an object with a mass that holds a rigid shape. Many of the equations for the mechanics of rotating objects are similar to the motion equation for linear motion. The angular displacement of a rotating wheel is the angle between the radius at the beginning and the end of the given time interval. The SI units are radians. Angular velocity is the rate of change of angular displacement and can be described by the relationship omega equal to delta theta over delta t. Angular velocity can be considered to be a vector quantity with direction along the axis of rotation in the right-hand rule sense. If the angular displacement happens smoothly like this, then the graph would be like this. The rate of change of angular displacement with respect to time is called angular velocity of the particle. If the rate of change is uniform, then the magnitude of the angular velocity is constant. The angular velocity time graph of a uniform rotational motion shows that the angular velocity remains constant over time. But in our question, the angular velocity is actually varies with the time. Actually, it is increasing uniformly. If this is the case, then the angular displacement should be accelerated. So here in these answers, the only accelerated graph is the fifth one. So fifth one is the answer.